Guys, if the applied force is 50 pound, we don't need to multiply it by 9.81. And it doesn't make any sense because 50 pound in US unit. And this is unit for force or weight. That's enough. We don't need to change anything. We don't need to multiply it by 9.81, and it doesn't make any sense because 9.81 is the acceleration of gravity in meter per second square. That means it's in SI unit. Some student in the homework number 2 did this, multiplied 50 or whatever the force by 9.81. It doesn't make any sense. We cannot accept this conversion because you multiplied something in US unit by something in SI unit. Doesn't make any sense. As I told you, 50 pound is a unit for a force or unit. You don't need to multiply it by anything else. But if the given weight in kilogram only, you need to multiply it by 9.81 meter per second square. This one is SI unit and this one is SI unit. That makes sense. So I can multiply this number in kilogram by this number in meter per second square. The final number will be in Newton. And Newton is a unit for force and weight. Last time, this is the last time because I covered this one time before. The last time, I remind you, if the given force in 50 pound or kib, that's it. We don't need to convert anything else. But if the force or the mass or the weight given in kilogram, you need to multiply it by 9.81. Okay. You have some question regarding. Okay, wait a moment for the exam. Until this moment, I don't have enough information about the exam. It will be a proctored exam. It will be provided by the university. So more information will be provided later by the university, and I will forward this information for you. But until this moment, what I know, we have proctored exam. You will not do exams like quizzes, staying at home and solving exams. No, you will do something different. What is this something? I don't know. I don't have enough information until this moment. I will provide you with all information once I received them. Any other question? Yeah, one more thing. I would like to highlight this. It's okay for me until this moment because some students during the homework and the quizzes also, they are using something like this. T1 divide sine something equal T2 divide something sine something equal T3 divide sine another angle. If you have 3 forces like this, so if you are looking for force T1, you will divide by sine this angle. If you are looking for T2, you can divide by sine this angle. If you are looking for T3, you can divide by sine this angle. Okay, that's good. But it's not a general case. We need to learn how to break forces to 2 components. Then we need to apply summation of all horizontal component and summation of all vertical component. With this method, break force to components will be more useful during this course. Probably this one is okay if you have 3 forces. But if you have more, 4, 5, 6, 7, if you have something different, no, we need to go back to my method, how to break forces to 2 components. Okay, I accepted this solution during the homework and the quizzes. I didn't cover this way in my class, so I assumed you are reading something different from a textbook or something. I assumed something like this. I will not assume something different, okay? Okay. Let's go back to our class today. We covered, just a reminder, one more reminder. In the first week, we covered forces in 2 dimensions. What you mean by 2 dimension? I mean X and Y dimension. I didn't mention anything perpendicular to my screen. So if you have a system of forces, any number of forces, all of these forces are concurrent, means intersect at one point. So I can break each force to 2 components, and I can get summation all of horizontal component, which means summation f of x, summation all vertical components, summation f of y. So I can get the summation of all horizontal components, summation of all vertical component. I can get resultant force equal this number square plus this number square. I can get the angle for this resultant force equal inverse tan the vertical component divide the horizontal summation of the vertical component divided by the summation of horizontal component. In the second week, we learned if you have particle in equilibrium. So we have forces, many forces. And all of these forces are in equilibrium. That means if you break each force to 2 components, I can say summation of all horizontal component equals 0. Summation of all vertical component equals 0. Only if these forces are in equilibrium or this particle in equilibrium. We will repeat all of this stuff. But if you are talking about forces in 3D, what you mean by 3D? I mean we have 3 axes, one called X, one called Y, and one called Z. If you are talking about 3D, so sometimes we have forces in 3D in the real life, because the real life is 3D. So we need to figure out what's going on with forces in 3D. Also, it will be the same sequence. We need to break each force to how many components in this situation? I believe I need to break each force to 3 components. 1 component in X, 1 component in Y, and 1 component in Z. This is the only difference. This is the only difference between what we learned before and what we will learn this week and the next week. So I'm talking about forces or concentrated forces in 3D. 3D means we have 3 axes, one called x-axis, one called y-axis, and one called z-axis. We have something, I believe you learned this stuff in mathematics. We have something called unit vector in x direction, which called I. We have something called unit vector unit vector called J, and we have a unit vector in Z direction called K. So I and J and K called unit vectors. I in X direction, J in Y direction, K in Z direction. So if you have a force called A or F, whatever, this force will have three components. One called AX in X direction, so I will multiply it by unit vector I. We have component in Y direction called AY, will be multiplied by J unit vector in Y direction. And we have the third component AZ will be multiplied by K as a unit vector in Z direction. So your force A as a vector, this one called vector. We have three components, one in X, one in Y, and one in Z. What we learned before, each force has two components only, one in X and one in Y, because you are talking about 2D. But right now, we are talking about 3D. One more time also, if you have a force with three components in X and Y and Z, I can get the value, the scalar value of this force by square root of horizontal component square plus, X component square plus Y component square plus Z component square, all of them under square root. So I can get the scalar value of a force. So if you have a force as a vector, I can convert it to a scalar value. If you have a scalar value, how can I convert this value to three components? We will see. Examples of forces in 3D, like this one. We have X direction, we have Y direction, and we have Z direction. We have many things in 3D. This cable, this member or this member, and this vertical member. So we have different dimensions, X, Y, and Z. Something looks like this tower. We have a three dimension, X and Y and Z. Like this one, we have three dimension, X and Y and Z. If you can break each force to three components, I can get the resultant force. How? Okay, your resultant force as a vector will be summation of all horizontal component plus summation of all Y component plus summation of all Z component. So we can add components together. It will be fine. It will be good. It will be easy. But the question right now, how can, if you have a force F in 3D, X, Y, and Z, how can I break this force to three components? This is the question. This is the main important question. How can I break a force in three components, in X, Y, and Z? This is the question. Actually, we have three cases also, but they are completely different than we learned before. We have three cases. Let me go through the first one. First case, very important. Very important. This case is very important. We need to learn three things in this case. What you have first, we have three dimensions, X, Y, and Z. We have a force, probably called A or F, whatever. We need to break this force to three components. The first component in X, the second component in Y, the third component in Z. For this force, we have three angles given. Three angles are given. Alpha, beta, gamma. The first angle, alpha, between the force and x-axis. Here is the x-axis. So the angle between the force and the x-axis called alpha. Beta is the angle between the force and y-axis. Gamma is the angle between the force and z-axis. So we have three angles. The first one between the force and the x-axis, the second one between the force and y-axis, the third one between the force and z-axis. I'm talking about positive direction of these axes. So positive direction of x, positive direction of y, positive direction of z. So your angles must be measured between the force and the positive directions of these axes. If you are looking for horizontal component, it will be a cosine alpha. I'm sorry, not horizontal. The component in x-axis, it will be a cosine alpha. Y component will be a cosine beta. Z component will be a cosine gamma. Let's do it here. We have example. We have a force R called how much? 30 kilonewton. Given alpha equal 40, beta equal 70, gamma equal 57. We need to convert this force R to a vector. Okay, R as a vector equal 30 cosine alpha 40 I plus 30 cosine beta 40. I'm sorry, 70 J plus 30 cosine gamma, which is 57 K. So your final answer will be 30 times cosine 40 equal 22.98 I. 30 times cosine 70 equal 10.26 J. 30 times cosine 57 equal 5.6 K. So this value is the components in x-axis. This value is the component in y-axis. This value is the component in z-axis. So I break this force 30 kilonewton to three components, one in x, one in y, and one in z. Any questions so far? It's very easy. Just give me the force and give me three angles. First one between the force and the x-axis, between the force and y-axis, between the force and z-axis. Whatever I made here a mistake, there is beta equal 70 and this gamma equal 57. I'm sorry. Anyway, it will not change anything. So this one is alpha, beta, and gamma. Any questions so far? Okay. We need to learn something also. We have a relationship between these three angles, alpha, beta, and gamma. We have a good relationship. Cosine square alpha plus cosine square beta plus cosine square gamma equal 1. But this relationship in your mind. We have a relationship between these three forces. Cosine square alpha plus cosine square beta plus cosine square gamma equal 1. Put this information in your mind. One more thing. If you have if the x component is given and the force is given, I can figure out the alpha, the angle alpha. Y component is given, Z component is given, so the force is given as a vector. So I can figure out the three components. If you divide this component by A, I can get cosine alpha. So inverse cosine, I can figure out the angle alpha. Y component divide A equal cosine beta. So if you get inverse cosine, I can figure out the angle beta. So these relationships are very important. Keep them in your mind. This case, we are talking about direction cosines. We are talking about a given force with three angles. The first one between the force and the x-axis, the second one between the force and the y-axis, the third one between the force and z-axis. Let me do one more example. We have two forces, F1 and F2, and we are looking for components of each force. What is the Cartesian coordinate? Means components. What are the components of each force? Let's start with F1. For F1, what is the value of F1? F1 is given 5 kilonewton. Perfect. How many angles are given for F1? I can see only two angles. Wow. Okay, the first angle 60. What is the name of this angle? I think this angle can be called alpha, equal 60, because alpha is the angle between the force and x-axis. Second angle, beta, between the force and y-axis. Do you have any given angle between this force, F1, and this axis, y-axis? No. Okay, beta is not given. What is the third angle, gamma? Angle between the force and z-axis. Do you have an angle between this force, F1, and z-axis? I think yes, 60. So how can I get the components of F1 and I missed one angle? We should have three angles. So how can I figure out the third angle? Any answer? Guys, in this example, for F1, we have only two angles given. The first one between the force and the x-axis, the second one between the force and z-axis. So I'm looking for the third angle between the force and y-axis, which is beta. How can I get beta to get the components of F1? Okay, perfect. Thank you. Thank you. Bikram. We have here, this relationship is very important. This relationship, very important. If two angles are given, I can figure out the missed third angle. Let's see. Cosine square alpha plus cosine square beta plus cosine square gamma equal 1. So cosine square 60 plus cosine square beta plus cosine square gamma equal 1. So I can figure out the value of cosine square beta. Get your values for this one and this one and move them to the other side. So cosine 60 square, don't forget square, plus cosine 60 square. So the other side will be negative plus 1. So this value equal 0.5. So cosine only beta, because this one is square, so I will get the square root of this number will be 0.707. Inverse cosine, this angle will be 45 degree. So beta equal 45 degree. This is the first step. Second step, we are looking for F1 as a vector. Will be X component will be your force 5 cosine alpha. I 5 cosine 45. J 5 cosine 60. K. So 5 times cosine 60, this value will be 2.5 I. 5 times cosine 45 degree, this value will be 3.5 J. And this one will be 2.5 K. So finally, for force F1, I break this force to 3 components. One in X, one in Y, and one in Z. This is a component in X-axis, component in Y-axis, component in Z-axis, using 3 angles, alpha, beta, gamma. Alpha, beta of gamma, at least 2 of them must be given. So I can figure out the third one using this equation. Once you have the 3 angles, I can figure out the component of the given force. We still have another force. We are looking for components of F2. F2 is very easy. Why? So right now I'm looking for F2 as a vector. F2 in Y direction. So we don't have X component. We have Y component, which is negative 2J. We don't have Z component, which is 0K. So F2 as a vector is very easy because this force is going in the same direction of Y-axis, actually in the negative direction of Y-axis. So we have only negative components in Y and 0 component in X and 0 component in Z. So in this example, we learned how to break each force to 3 components. Any questions so far? Any questions so far? This one is very easy. We need to figure out 3 angles to be able to break this force to 3 components. Sometimes the given force in one axis, so it will be more easy. In this case, your force F2 in negative direction of Y, negative means negative direction means minus, and we don't have anything in X and we don't have anything in Z. Okay, second case. We have 3 cases. We will cover today 2 cases. We cover the first one. Second one. We have a force. This force is going between 2 points. I can figure out the coordinate X, Y, and Z of the first point. And I can figure out the coordinate of the second point, X, Y, and B. We have a force. This force is going between point A to point B. And I need to figure out this force as a vector. What are the components of this force, x component, y component, and z component. We covered this a little bit before. Okay, this force as a vector equal this force as a scalar value, as a value, because this force sometimes 5, 10, 30, 300, 600, whatever, time. This force is going from A to B. So x coordinate of B minus x coordinate of A, I. Y coordinate of B minus y coordinate of A, J. Z coordinate of B minus Z coordinate of A, K. Divide square root of this value, xb minus xa square. Second value, yb minus ya square. Third value, zb minus za square. This formula is very easy. Just don't try to copy it. No, just go ahead and understand it. X coordinate of the second point minus x coordinate of the first point. Y coordinate minus y coordinate. Z coordinate minus z coordinate. This is the numerator. Denominator, square root, this one square plus this one square plus this one square. All of this stuff multiplied by the value of the applied force. Let me do this example. We have a force, how much? 250 Newton, F. This force F is going from point A to point B. So point A will be the first point, point B will be the second point. It's very important to determine your force is coming from A to B or B to A. Very important. In our case, this force is coming from A to B. And the value of this force, the scalar value, 250 Newton. I'm looking to convert this force to a vector. If you can get the vector, I can figure out the x component, y component, and z component. Okay, your f as a vector equal f as a value 250. Then what? You said from A to B. So the second point minus the first point. So x coordinate minus x coordinate. So 4 minus 2. This value I. Y coordinate minus y coordinate. So we have 3 minus 5. J. Z coordinate minus z coordinate. So we have -1, -6. K. Divide square root of 6. Square root of 8. I'm sorry, square of 8 plus square of -7. Guys, 6, 4 minus -2 is 6. 3 minus -5 is 8. -1 minus 6 is -7. So go ahead and simplify these values. So this one will be 6i plus 8j minus 7k divide 6 square plus 8 square plus 7 square under square root. This one will be 12.2. More simplification, 250 time 6 divide 12.2. This one will be 0.49i plus 8 divide 12.2. This one will be 0.65j minus 7 divide 12.2. This one will be 0.57k. More simplification, 250 times 0.49. This one will be 122.5i, and this one will be 162.5j, and this value will be 142.5k. So finally, I can figure out the three components of this force 250. The x component equal 122.5, the y component equal 162.5, the z component equal negative 142.5. How can I convert a force to three components using coordinates? We have a force coming from point A, and the coordinates of point A are given. To point B, and the coordinates of point B are given. Okay, your force as a vector equal this force as a scalar, as a value, time x component of the second point minus x component of the first point. Y component of the second point minus y component of the first point. Z component of the second point minus z component of the first point. Which one is first point? Which one is second point? This force is coming from A to B. So A is the first point, B is the second point. Then divide this value, square root of this value square, plus this value square, plus this value square. So I can get these numbers, and I can simplify all of this stuff to finally get three components, one in x, one in y, and one in z. So one more time, until this moment, I covered two cases, the most easy cases in 3D. 3D is nothing. 3D is very easy. The first one, sometimes the given force is given with three angles, alpha, beta, gamma. We learned three things in this case, in this situation. The first one, we have a relationship between these three angles. Cosine square alpha plus cosine square beta plus cosine square gamma equal 1. Second thing, if you would like to get the components of this force, okay, the force cosine alpha, the force cosine beta, the force cosine gamma, so I can figure out the three components. If the components are given, x component, y component, and z components are given, and the force is given, so I can figure out your alpha and beta and gamma. Second case, we have a force passing through two points, and the coordinates of these points are given, or I can figure them out. So your force as a vector equal this force as a value time x coordinate minus x coordinate I, y coordinate minus y coordinate j, z coordinate minus z coordinate k, divide these numbers square under square root. It's very important to determine which point is the first one and which point is the second one, based on the direction of the given force, because you are talking about coordinates of the second point minus coordinate of the first point, coordinate of the second point minus the first one, coordinate of the second point minus the first one. So I can convert this force to three components. Any question? Guys, if any question, this one is a tricky case, we will cover it next time on Friday. But until this moment, any questions so far? Before leaving, I have a question. Can you look to this slide, please? Slide number 9. We have a force and we have angles. Can you tell me what is the difference between this situation or this case and the first case? Let me go back to slide number 9. Anybody can tell me what is the difference? What do you think here? We have alpha, we have beta, so we can figure out the third angle. So what's the problem? No, f is given. And these angles are given. Just to clarify the first case, we have x, we have y, we have z, and we have a given force, and we have 3 angles. This one, alpha, this one, beta, and this one, gamma. What is the difference between this case and this one that we will cover on Friday? Look to these figures and tell me what is the big difference. Because if you cannot understand the difference, you will not understand what I will cover on Friday. Thank you, Mitchell. Thank you. Thank you. Michelle, you are very close, but Mitchell, alpha is not given to the x-axis. This is the main difference. This is the main difference. If you have angles, alpha, beta, gamma, or whatever the names, 30, 40, 75, whatever, I don't care about the names, alpha, beta, gamma, theta, phi, whatever the names. But you need to remember something very important. These angles between the force itself and the axis. So alpha between the force and the x-axis. Beta between the force and y-axis. Gamma between the force and the z-axis. So we have something identical for all of them between the force and the axis. But in this case, can you look to this one? We have 2 angles, alpha and beta. Okay, the first one, what is the angle alpha? Between what? Between what? Between the force and what? Wow. Between another line, it's not x-axis or y-axis or even z-axis. Beta between x-axis, good, and what? Something different than the force. So we have a very big difference. We have a different situation here. These angles are completely different. Alpha is given between the force and the something here. Beta between x-axis and this something. In this case, we have alpha between the force and z. Perfect. This is good. But the second angle beta between the x-axis and the something here. Oh, so this one and this one are completely different than this one. One more time. This one, you have a force and you have 3 angles. The first angle between the force and the x-axis. The second angle between the force and the y-axis, the third angle between the force and z-axis. But if you have angles different, we need to think about this, and I will cover all this stuff next this Friday. No, we will not. We will cover this on Friday, but at least at this moment, you can figure out the difference. Okay? Okay, so sometimes you will see something like this in the problem. Sometimes you will see something like this in the problem. So we need to first define which case I will use. This case is clear for you right now. This one will be more clear next or this Friday. Okay,